Okay, some of you are struggling a little bit with force diagrams, so I'm going to start off by just going through what the four forces that you need to be concerned with at level 1 are. I'm going to just use, for simplicity, boxes. So I'm going to start with a box, and we're going to assume that any movement is from left to right. So we've got four forces acting on this box. We've got a downwards force, which is the weight force, and this is due to gravity. And we've got an upwards force, assuming that the box is sitting on a surface, a desk or a floor. We've got an upwards force, which is called the support force. This stops the box falling through the table or through the floor. If we apply a force onto the box, we apply maybe a push force or a thrust, and any surface it's on or the air will provide a force against that push, which is a frictional force. So these are our four main principal forces that you need to be concerned with. So weight moving downwards towards the centre of the earth, support force that is stopping it falling through whatever it's sitting on, the push force, which is the one that you apply, and then there's the frictional forces that go against that force that you've applied. So here we have the same box but with some numbers applied. This is actually the first example of question 2 on page 36. So we've got, what you need to do is look at the opposites. So we've got the weight force here of 24,000 newtons. Now newtons is our unit of force, named after Sir Isaac Newton, who originally discovered or realised that forces were acting on objects. So we've got 24,000 newtons acting in this downward direction, and the support force is also 24,000 newtons, and that's acting against the weight force. So we always look at our opposites. So we need to look at these two numbers, and these two numbers are the same. So these two values will cancel each other out, leaving an up and down force of 0, nothing. So if we take 24,000, take off 24,000, equals 0 newtons. There's no force acting in an up and down direction. Now if we look at the other two opposites that we've got here, we've got 5,000 newtons in our push force, and we've got 6,000 newtons in our frictional force working against us. So we've got 6,000. So we always take the bigger number, take away 5,000, and that equals 1,000 newtons. That's our net force. And our net force has direction, so we look at where the bigger of these two numbers were, the 6,000, which is here. So our bigger of our two numbers is 6,000. We're taking off our 5,000, and that leaves us with a net force of 1,000 newtons in the right to left direction, in the reverse direction. So the direction of the force is backwards. This vehicle, because it is a car in the book, you'll see, if we assume that it was in motion, it was moving in the forward direction, and now it's got 6,000 newtons working against that forward direction, this will be slowing down or decelerating. So just to recap, we always have to look at our opposite forces have a look. If they're the same, there's going to be no change in motion. It will stay still, or it will carry on moving at a constant speed. If there is a difference in the forces in the opposite directions to each other, so our 5,000 and our 6,000 are working in opposite directions, we have a net force of 1,000 newtons, and that means that the motion is going to change. Either the vehicle is going to speed up, or as in this case, because it's the friction forces that are bigger, it is going to be slowing down or decelerating. Another way of saying this, another way of looking at this, is that these forces are unbalanced. They are not the same in all four directions. The opposites are not cancelling each other out. Maybe we'll just have a look at an example where the forces are balanced so you can see the difference. So here we've got the same box again, and as mentioned before, we've got our 24,000 newtons for our weight force and our 24,000 newtons for our support force. And just as before, if we take those two numbers away from each other, we've got 0 newtons acting in an up and down direction. But this time our push force is still 5,000 newtons, but I've changed the frictional forces. Maybe they've gone onto a smoother road or something, and so our frictional forces are also 5,000 newtons. So notice how I'm using our opposites here, our push and our frictional forces. So 5,000 take off 5,000 equals 0 newtons. So here we've got 0 newtons in our up-down direction, 0 newtons in our forward reverse direction. So there is a 0 or no net force. We can say that our forces are balanced and there's no change in motion. So whatever that box or that vehicle or whatever object it is, whatever it is doing, it is going to carry on doing the same. So let's say that it was moving at a constant speed, it is going to stay moving at the same constant speed. Or if it is stopped, if it is at rest, it is going to stay at rest until one of those forces or pairs of forces become unbalanced.